Hello students, welcome to Doubtnet. Let us look at the question here, which says that carbon-carbon bond length is maximum in, and we have been given here four options. We have diamond, graphite, naphthalene and fluorines. So in this question, we need to find out the structures of all these options that have been given here, and later on we can decide that out of all the options, which of them has the highest or the maximum, we can say, carbon-carbon bond. Okay, bond length. So first of all, let us start with diamond. Okay, so diamond is, as we all know, the carbon atoms in diamond is sp3 hybridized, right? And it has the tetrahedral structure, right? So it has tetrahedral geometry and it looks something like this. So carbon is, every carbon atom is attached with four other carbon atoms like this. Okay, something like this, right? And also we can say here that carbon here, every carbon here has four valence electron, right? So they all are paired in bonding orbitals, and this is the reason why carbon here is stable and diamond as a whole behaves as an insulator. So let me just write it down. So we can say all the four valence electrons are paired in bonding orbitals. Okay, and this is the reason why diamond behaves as an insulator, right? So this is something that we can talk about diamond. Also, it has a very high melting and boiling point, and it is one of the hardest substances that we know of, right? Now, there is something that we need to know about carbon here, diamond here. So all the carbon atoms are attached with a pi bond having the bond length of somewhere around 154 picometers, right? So let me just write down here. So here all the carbon atoms are attached with a pi bond, a sigma bond, not pi bond, sigma bonds, right? Having a bond length of 154 picometers, right? So this is the bond length that we get in a diamond structure. So carbon-carbon bond length we have as 154 picometers, right? So this is something that we can talk about diamond. Now let us move on and let's talk about the another one that we have here is graphite, right? So we have graphite, which has layered structure, right? So in graphite, each carbon atom is bonded with three other carbon atoms, right? Giving sp2 hybridization. Okay, so first of all, let me write that, and then we will later on we can just draw the structure of graphite. So in graphite, each carbon atom is bonded with other three carbon atoms. Okay, and giving sp2 hybridization. Okay, now this can be represented as a resonance hybrid in which every bond has a partial double bond character, right? So later on it can be represented as a resonance hybrid And this resonance hybrid is is something like in which every bond has a partial double bond character, right? In which, I'll just write it down so that you can refer it, in which every bond has a partial double bond character, right? And we know that double bond where we have a sigma and a pi bond has more overlapping than we can say than sigma bonds, right? Alone sigma bonds alone. And this is the reason why, when more electrons are involved, we see more overlapping, and when more overlapping is seen, the bond length, it eventually becomes smaller, right? So let me just draw the structure of graphite. So it has a layered structure. Okay. So it looks something like this. Let me just draw it first. Okay. So this is how a graphite structure looks like. Okay. We are not being very precise here, but just to give a peek of it. Okay, and the resonance structure has so it looks something like this. Okay, now this is the double bond, right? So every bond some way or the other it behaves as a double bond, right? Just because of the resonance structure. So this is how a graphite structure looks like. So here we can see that it has a sigma and a pi bond both. So if we have to just talk about this, so it has both sigma bond, right, and a pi bond. Okay, so having a shorter bond length than diamond. Why? Because we have already discussed, right? Because when pi bond and sigma bond are together, we have a double bond structure. So 4 of the electrons are involved. So we see that there is more overlapping, and then there will be more overlapping, then we can see the bond length decreasing, right? So this will be having a bond length of, so in graphite, the bond length that we see is somewhere around 141 picometers, right? So in diamond, we have seen a bond length of 154, but just because graphite has both sigma bond and pi bond, so just because of the double bond, we can see a shorter bond length here, right? Now moving on, the next that we have in our list is naphthalene. Okay, so we have naphthalene, and naphthalene structure looks something like this. So this also has, it looks like 2 benzene structures are, they are merged together. It has a feel of that, right? So it is naphthalene is we have C10H8, right? And this also has a double bond character, and this is sp2 hybridized. Okay, so here all the carbon atoms in graphite also has sp2 hybridization. This I have missed. Okay, and here also naphthalene also has sp2 hybridization, and here also we can see double bond mixing with so we have a pi bond and sigma bond. So this has a bond length of 137 picometers, right? So naphthalene has a bond length of 137, which is again shorter just because of both pi bonds and sigma bonds. So double bond character makes a bond length smaller. Okay, now moving on, we have fluorines. Okay, so fluorines here had a football structure. Okay, so we won't be able to draw the structure because it's pretty complex, right? So it has football structure or football shape and has a combination of, again, it has a combination. Let me just write it properly. Just like graphite and naphthalene here, it also has a combination of sigma and pi bond, right? And have a bond length of, so the bond length that we see in fluorines is around 146 picometers, right? And this also has the hybridization, which is sp2. So every carbon atom in C60, which is the fluorine, so 60 atoms are arranged in a football structure, and it also has the combination of pi and sigma bond, so double bond we can see evidently, and this is the reason why it is sp2 hybridized, and it has the bond length of 146 picometers, right? So if we just compare the bond length and the structures of all the options that have been given here, so it is pretty much clear that the diamond that we have here has the maximum carbon-carbon bond length, and rest all of them are not having the maximum bond length, so these are the incorrect options to us, right? So this is how we can understand this question. I hope you all also understand. Thank you.
ये हमारा बेसिक क्वेश्चन है इनऑर्गेनिक का. अगर आपको आता है तो आप कर पाएंगे, अगर आपको नहीं आता तो आप नहीं कर पाएंगे. उन्होंने पूछा है कि बेसिक यूनिट ऑफ जियोलाइट, माइका, एस्बेस्टोस और फेल्ड्स्पार का क्या है. रट्टे वाला क्वेश्चन है. अगर आपने रट्टा लगा रखा है कि इनका बेसिक यूनिट है SiO4 4- तो आपको नंबर मिल जाएंगे, वरना नहीं मिलेंगे. बहुत ही सिंपल क्वेश्चन है, सीधा आंसर है SiO4 4-.